Okay, let's give you guys some practice. Now, if you look at a 3D elephant, the because the build of an elephant is similar to a block, because you can actually map it onto a block, because the build of an elephant is so similar to a block. Most people, well, some people can assume that the mass of an elephant, is proportional to the cube of its height. Okay, you can actually make this statement, and it's quite realistic as well, because if you look at the cube, if this length here is x, uh, the the volume here is proportional to the cube of x. Now, because the build of an elephant is so similar to a block, you can actually make this statement. Now, I don't know if the same is true for a giraffe, because a giraffe, the build of a giraffe is so different. It's not really blocky. So I'm not sure if you can make this statement here, where for a giraffe, but it's quite realistic to be able to make this statement. The mass of an elephant is proportional to the cube of its height. Okay. Now, if this is true here, maybe you can think of an animal where so if you look at a sphere, you know the relationship between the radius of the sphere and its volume. So if you can think of an animal that you can map on, that you can map into a sphere, or onto a sphere, you can actually make a similar statement where the radius of that animal is, well, you can make a similar statement, but I wouldn't map a starfish. So you got a starfish here. I wouldn't map this onto a sphere, because a starfish is kind of flat. So maybe you can map it onto a flat circle and make some sort of statement about this starfish by using a flat circle as opposed to a sphere. Maybe there's an animal out there, some sort of fish or something, where it's I don't know. There might be some spiky animals out there. I can't remember which one. You can map this onto here, and maybe you can make some statements about the mass of this starfish by using what you know about the sphere. Okay, but we've done several videos on the sphere. You know the relationship between the radius and the volume, so maybe you can make a similar statement by saying, oh, the mass of this animal here is proportional to to its radius cube, or whatever. You can make a similar statement to what's being made here. Okay, well, anyway, so you've got this elephant here. Okay, so a zoologist can assume that the mass of an elephant is proportional to the cube of its height, and this statement alone, it does make sense, and it's kind of realistic. It is kind of realistic. I know it's a bit strange, but it is kind of realistic. Okay, well, anyway, given this statement here, okay, so you can summarize that as mass is proportional to the cube of the height. So there, you can summarize this now. So from this, you can jump to m equals k, uh, m equals k, and then h to the power 3, something like this. Okay, so now, well, anyway, uh, so a young elephant has a mass of this, and a young elephant has a mass of this and a height of this. So you've been given in a way, a system, one example of the system. Now you can use this to find your value of k, to work out the mass of an elephant when it's at a height of 2.1 meters. Well, anyway, press pause and answer this question here. Okay, so press pause. Okay, so to do this here, this statement here, you can summarize it as this: mass is proportional to the height cubed, and then from this you can jump to m equals a constant h to the power 3. Now you're given an initial condition, if you like. A young elephant has a height of this, so now you know the height. Okay, you put in there, and you know the mass here, so you put it in here to find out your K. So mass equals 300, uh, and then you have your K, and then 1.3 to the power of 3. Okay, so it's just a matter of working out K. So K here equals 300 over 1.3 to the power of 3. So just jump to your calculator, clear it. Because my calculator is rubbish, I'm going to do this first. 1.3 to the power of 3. I'm just going to do 1.3 times 1.3 times 1.3. Okay, that will give me that. So put it into memory store. Hang on. Okay, so now it's 300 divided by what was in the memory equals this. So my value of K here is I'm just going to round it off to 137. Okay, 137 equals K here. Okay, so now we've got a formula now. So here, because we found our value of K here, we can put it into that formula. So M equals 137 h to the power of 3. Now this is our magical formula now. From this, we can work out this question here. Find the mass of an elephant when it has grown to a height of this. So now we want to know the mass of an elephant when it has this height. So put this into here. So this would be, hang on, this would be M equals 137 and then times 2.1 to the power of 3. Okay, so calculator, clear this. Okay, so it's going to be 2.1 to the power of 3. I can't find that button, so I'm going to do 2.1 times 2.1 times 2.1 equals this, and then just times by that constant. So times 137 equals this. So the mass of the elephant will be hang on, mass of the elephant will be 1 2 I'm going to round off 9 kilograms. Okay, so this here will be your answer here. Okay.